Hi, thanks. Say thanks for having me here. Yeah, so let's move along a bit. So I'm going to talk a little bit about today about evolving your infrastructure. So infrastructure as code being kind of one of my core interest area. It's about how to use automation to make your infrastructure more kind of adaptable and something that you can manage and change as your needs change. So just a little bit about myself, I guess a little bit more about myself. So I joined Thoughtworks about 10 years ago almost, and I had been working 10, 12 years in the industry before that. And I'd been working across different roles in systems administration and development and kind of going back and forth before it became a thing. I used to have to try to explain to people why I didn't want to just kind of stay in kind of one side of that divide. And then DevOps became kind of a thing and kind of legitimized doing that, which was nice. And so when I joined Thoughtworks, it was when the continuous delivery book had just come out. And so a lot of what I was doing was working with our teams where we're going into an organization to help with software delivery and software delivery practices. And those organizations wanted to do continuous delivery. Like we want to do this thing where we can get our software into production more easily. And what I found was, well, because of my background, what I was intended to be doing on those projects was I tended to be helping with the infrastructure, with like how do we, in order to make that continuous delivery work, we have to make sure that our environments are consistent from development through to production. So I found myself working a lot with our clients' operations teams and infrastructure teams on how to use kind of emerging, at the time, very emerging technologies around virtualization and cloud, as well as the automation tools like Chef and Puppet to make this work. And what I found was that it wasn't, people, even though people were adopting the tools, they weren't really understanding how to get the best use out of them. And so I was also kind of learning a lot, having joined Thoughtworks, so I was learning a lot around agile engineering practices, test-driven development, and continuous integration, continuous delivery. I was learning a lot and naturally applying them to the infrastructure and learning a lot for the industry. And so that's where the idea of the book came from. Infrastructure as code is a phrase that had been around, and I just kind of like adopted it as like, nobody else had yet written this book about how to use these tools in kind of a cohesive way. And so I figured it would be useful to kind of share patterns and things that I'd learned and worked out with people. And I guess one other kind of comment I guess I'd make, it's really quite cool coming here to Australia because it's my first time here. But it's the cool thing I think is that within Thoughtworks, it's like we have this global community. So we've got a couple of people. We've got kind of Tom and Innie who I've worked with. They're coming up here to speak a little bit later today. But I worked with them in London. And then I've got other people like Effie and Kate, who I know from the community. I haven't met them until today, but like, we've got this amazing kind of global community where we just kind of share ideas and experiences and even work together on projects across the globe. So it's quite cool to come here and just find that, it's still kind of the same people and the same kind of vibe wherever I go. So the kind of, I guess, driver for all of this stuff with infrastructure as code is around this use of cloud, right? So a few years ago, the common pattern we'd find in organizations, we'd go in and they'd be wanting to, do the new stuff online, do the digital thing. And so they were setting up new departments and separate teams or groups or even companies that were doing the digital thing separately from the rest of the organization. The thing was that they would tend to find that their existing IT organization was maybe too slow, a bit too bogged down in processes and governance and so on. And so they'd say, we're going to leave all that behind. We're going to do stuff on the cloud because we can just set up whatever we want without having to ask permission. And we can kind of just go as fast as we want, which was really compelling at the time. And then what's happened over the years is that the things that people were doing in this kind of special sideline digital thing got more and more traction. So there was more kind of business being done, more money flowing through platforms or more kind of important things to the business or the organization happening on the cloud. And so we had to worry now about all those kind of processes and governance that we left behind. Hey, actually, there's reasons for that, right? We have to kind of take care, partly because if we're dealing with kind of more money going to these online platforms, we have to worry about the kind of financial risk. There might be more governance and compliance involved now, and then also there's just the fact of the responsibility, right? You're dealing with people's data and personal information and their money, and so you have to kind of treat it with a bit more, I guess, kind of respect and care than maybe we did in the early days. So the idea of kind of managing that risk on the cloud is basically, I think one of the things that, well, what we had to kind of do, and what a lot of people have to kind of do, we have this, I think, natural tendency to think about there being a trade-off, right? We think we have to trade off between, on the one side, going quickly and having a fast throughput, and on the other side, kind of stability and quality. And we think, well, we have to decide how to balance these things, right? At least that's kind of the natural belief, right? So the idea is that we think, if we go fast, that means we're going to be unstable. We're kind of neglecting quality. We're kind of doing the move fast and break things. And then on the flip side, we say, if we're going to focus on stability, that means we have to accept poor throughput. We have to accept that things move slowly if we're going to do things properly and carefully, right? This turns out to be, so there was some research. How many people are familiar with the Accelerate book or the State of the DevOps report? That's a fairly good awareness. But so for those who aren't aware, basically for the past kind of 5-6 years, this group that's now kind of organized and called the DORA group, the DevOps Research Group, have been doing research. They've been doing surveys of organizations around their IT practices. So the things that we talk about with kind of agile practices and DevOps, they find, they've asked organizations which of these practices they use and how they use them. And they also look at what they call their performance. So they talk about high-performing organizations. And they're trying to build some correlations and find out which practices that we've been talking about, without necessarily having the evidence, which ones actually correlate to performing well. And when they talk about high performance, what they mean is the organization meeting its objectives, whatever those objectives are. So whether that's revenue, share price, or other kind of things that they're trying to achieve as an organization, how well do they meet their own objectives? And so they kind of correlate what are the practices that work. And so there's a couple of metrics, and we talk about this on the Thoughtworks Tech Radar. We call out these 4 metrics. And these are basically the things that they found have the highest correlation. So there's lots of things you can measure in your organization. There's things like uptime, for instance, is a popular one. What they found is that doesn't necessarily differentiate. So organizations that perform well or perform less well don't necessarily have that great a difference in their uptime, for instance, but they do have a greater difference to these metrics. So these fall roughly in the kind of the throughput. So how frequently do you deploy changes into your production environment? And then what's the lead time for the change? From kind of identifying and saying, look, we need to make a change, whether it's because there's a bug that we need to fix, a new feature we want to introduce, or a new product we want to release. How long does it take from us having that idea or identifying that need and actually getting it then into the hands of our users? And then there's the stability metrics. So the change fail rate is how many times when we make those changes to production do we have to either roll it back or make another change very quickly in order to correct it? How many times, how often do things go wrong when we make those production deployments? And then how quickly can we restore our service when something falls over or we do have a problem? How quickly can we get things up and running again? So these are the kind of 4 things, and they correlate, right, to that kind of speed versus stability thing. But the interesting thing from their research was that they found that there was not actually this correlation. There wasn't actually this trade-off, rather. It wasn't that you're either good at one side, you're either good at the speed, or you're good at the quality. In fact, they found that the high-performing organizations are good at both. They have good results in both of those metrics. And they also found that there weren't organizations which are good at one and not the other. So either you're good at both or you're not good at either one. And this was interesting, right? Because the shift from it's not intuitive, I think. And so for me, I think the way I've kind of like reframed this is rather than being this trade-off, I thought, well, I'm a consultant, so it's a quadrant, right? We like our quadrants. So if you think about this, if you think about this on this quadrant, you have the kind of move fast and break things quadrant, right? Where as an organization, this is a startup mentality. We need to move fast, and that's the most important thing. And we're not going to worry so much about the quality that can come later. And what those organizations tend to find is that actually they very, very quickly build up technical debt and messy systems so that they can't actually move fast. So they're not only are they sacrificing quality, they actually end up having to sacrifice speed because making changes is difficult because things break and they're spending all their time fighting fires. So then the flip side of that, if you go to kind of the larger organizations who say, we're going to prioritize quality and stability because, maybe we're a bank or something like that. And so we say, we don't mind going slow, we'll sacrifice speed in order to achieve quality. And these organizations tend to find the same thing. They end up in the same place. And this is, I think the reason for this is if you go into these organizations, you find there's actually quite a lot of technical debt. And that's, to be fair, that's often because the organizations have been around for a while, so they've built up a lot of legacy. But I think there's also the fact that it takes them a long time to make changes is an impediment to quality. Because if you look at your system and you say, oh, here's something that's kind of not right, it's not on fire, it's not broken right now, but it's like, it's not kind of good quality, it's a bit messy. If it's going to take you 3-4 months or more to kind of go through the process of getting that change, to get the approval to change it and the kind of designs done and all the kind of things that you need to do to go through your process, you'll find you tend not to do that, right? Because you have more important things to do, and you start to build up this list of known issues. And so quite often in the large organizations which think, we're really good at quality, actually they're not really good at quality, they're just really good at taking a lot of time and having a lot of obstacles to making changes to systems. And that's not the same thing. And so what we're really aiming for, these high-performing organizations, and I think whether you call, whatever labels you want to put around agile, lean, DevOps, and so on, what it really comes down to is saying we're going to optimize for change, not just for the speed of change, but for the quality of change. We're making sure that we can make changes easily and quickly and continuously. And this is kind of the essence of it. Again, whatever the label you want to put on it, the essence is we want to be good at making changes. How many people are familiar with this book, The Building Evolutionary Architectures? Good number, good number. So this was really exciting for me when this book came out a couple years ago because to me it gets to kind of one of the fundamental kind of mind shifts that we need to make as an industry, which is going away from thinking of kind of static end states. So typically we'll go in, we can draw, in any kind of organization, people can draw their existing architecture, their existing systems, and point out like all the things we don't like about it, right? There's all these kind of problems that we have we don't like. And then we can go up and we can create the, people will go up and say, this is what we want it to be like, right? This is our end state, our target, and if we get the approval and the budget, then we're going to go and like rebuild everything and it will be like this wonderful new thing. But of course, what tends to happen is on the way to that new thing, various things happen. So you learn things like you have, like when we're going to use a new technology, we're going to use Kubernetes and Istio, right? Because that's the new hotness, and we're going to build it on that. But then as you're building it, you're learning those tools, and you kind of don't build it necessarily as well as you would like. And also, requirements change, and just, things are never kind of like, and also you have to take shortcuts because then you get time pressures, and you're like, oh, we'll just do this quickly, and we'll go back and clean it up later. And you end up with a new kind of legacy system, which is messy and hard to change. And then you start thinking about, okay, what's the kind of version 3 of this thing going to be? So instead of doing that, it's like we need to think about how do we design our system assuming it's going to change. And in fact, the building of the system in the first place is going to be through a series of changes. And that's just going to continue on. And so we make the assumption that our system is always going to be changing. So how do we kind of build that in, that assumption, and make that possible? So I'm going to talk today about 3 kind of core practices, I guess, around this infrastructure as code. And as I think Scott alluded to, it's like these are kind of core things that from engineering anyway, software engineering practices that we do anyways, but applied more to infrastructure. So one is, first of all, defining things as code, right? That's the kind of the baseline. Another one is continuous validation. So this is that test-driven development, continuous integration, continuous delivery, but applied to infrastructure. And then the third one is building things in small pieces. So this is the kind of architectural design thing of saying, let's build a small piece at a time. So for the first part of this is defining things as code. And so this is fairly basic, right? So if we say we're going to define our systems, our infrastructure as code as opposed to kind of using tools running it manually to build things, this means that everything is visible. So anybody can go back at any time and see how is this system kind of put together, what are the elements of it. We can reuse it because it's code. So we can say, okay, we've created a cluster for our applications and the databases and the networking and all that. We now have this code that we can run again and create a new cluster for whatever purpose we need to, and it's going to be consistent. It's going to be very much the same. And then also it's actionable, right? So this is kind of testable thing is that like because we have code, we can test what our infrastructure, how it's going to work and how our system as a whole is going to work before we apply changes to production. And so this is something we can do because it's as code. So the first kind of element of this, kind of like the baseline thing is having an infrastructure platform. And this is essentially cloud, infrastructure as a service type cloud, although there's different kind of formats for it. So the thing is that we have compute resources, we have storage resources, and we have networking resources that we can be provisioned on demand and programmatically so that we can use tools with an interface. So this isn't kind of, we used to have a few years ago the old school kind of hosting vendors who would say, we're giving cloud, we now have cloud because we know that's a cool thing, but it would still be like raise some change requests in order to provision resources. And so what we, in order to do this stuff, it can't be that. It has to be an actual, on-demand provisionable kind of thing. And so these are the kind of typical kind of cloud platforms. So it's obviously, it's like the public cloud platforms, but it's also possible to do it within data centers using things like OpenStack or VMware or whatnot. And so the idea of an infrastructure stack is kind of, that's the next level. This is like, so how do you kind of provision chunks of cloud, basically, right? A collection of those resources, of those storage and compute and so on, into something that's usable. And so a stack is something that, you have a definition file, some kind of code, and then you use that to provision and use the tool to provision actual resources in your cloud. And so these are the typical kind of tools, things like Terraform. Each of the cloud platforms tend to have their own similar tool that helps to kind of, that you can use to define things on that platform as code. And then there's also, some of the other kind of tools that are around for provisioning servers are also that, have kind of additional tools and things that they can use to play in this space as well. So then on top of that, if you can provision chunks of infrastructure in these stacks, then you want to have something to make that in a format that's usable to deploy applications, right? So the kind of classic thing in this field is virtual machines, right? EC2 instances or whatever. So this is kind of like the basic thing. You provision a server with an operating system on it, and then you can deploy your applications on top of it. There's also doing this with physical hardware. So for systems and applications which have a need to be kind of closely tied to the hardware, you can still do this by dynamically provisioning physical hardware, what you call kind of bare metal clouds, and then you can deploy applications onto those. That's still something you can do. And then the newer things that we're seeing is obviously container clusters, right? Things like Kubernetes are also like chunks of things that you define on that underlying platform that give you something you can deploy your applications to. And then serverless comes in again, saying, okay, there's less of the things that we need to worry about in terms of the details of what the servers look like that our code runs on. But we still have to think about, with all of these things, we still have to think about defining them as code. So our Kubernetes cluster, we kind of want to be able to say, how is that cluster configured? If I'm going to make a change to my Kubernetes cluster configuration, I'd like to test that in a non-critical environment before I put that into production. So having it defined as code and doing these same principles that we're talking about helps with that. And then similarly with serverless, okay, we say it's just a bit of code that runs, and I don't care about the server that it runs on. Well, you still probably care about, you may have connections coming in, network connections coming in to kind of trigger actions. You probably have things that are being stored or data being retrieved. So these are, the serverless code doesn't run in a vacuum. It kind of interacts with other parts of the system. And so that means we have to think about, how that's configured. And so even though it's less, the benefit of these technologies is that we have to worry about, fewer details. There are still things that we need to think about there. So the next thing we get to when we think about defining these infrastructure as code is how do we manage multiple environments? If we have like a development, staging, and production type environment, how do we use our Terraform or whatever to build these different environments? And there's a few kind of, I guess, patterns or anti-patterns that people tend to go through with this. So the first one is what is called the many-headed stack anti-pattern, right? And so people who are starting out with these tools, what they'll tend to do is to say, I need these different environments. I've got my Terraform project or whatever. And so I'll just make the servers and the networking structures for each of these environments within my single Terraform project. And then I'll run the Terraform command on it, and it will kind of like make changes to whichever thing it needs to. Now, the problem with this is that you have what we call a blast radius, a wide blast radius. So what will typically happen when you start working like this is at some point you find, I'm going to make a change to my test environment, and then I apply it, and then something breaks in production. because it's the same code base and there's something you maybe didn't realize was going to happen there. And so this is kind of something that once you kind of get to that point, you realize, okay, we need to move beyond that. So the next kind of thing that people do is this, what we call singleton stack. And the idea with this is, okay, now I'm going to take each of my environments and give it its own project, its own Terraform project, say. And so that way, I fix the blast radius problem because I make a change to the test environment code. I run Terraform against that, and it's not going to go out to production. It's just going to change the test environment. So then I can kind of copy my changes from one environment to the next. But this is the disadvantage of this. This is the problem with this, is that we're basically saying, what we do is we make a change to our test environment, we apply it, we see is it okay, and then we copy and paste those changes to the next environment, and then on to the next one. And that leaves us open to making errors, whether it's, we make a mistake in the copy paste, or what may happen is that actually in each environment we need to make some changes because maybe we have like some strings which say like this is the name of the environment. And so when you copy and paste, remember to go through and change everything from dev to staging and from staging to production. And then what happens is you forget one of those things and things break. Or what happens is you've got people working on different changes at different kind of paces. So it's like I'm making a change and I'm testing it out in the test environment, and I test it out in the staging environment. And then I get distracted as something higher priority comes, and I go and do something else while leaving that in the staging environment, and you come along and you're trying to make a change, and you accidentally copy my kind of half-done work into production. And so this kind of ends up looking pretty much like we have in the pre-infrastructure as code environments, where we've got these environments that don't kind of, they're never quite the same, they're never quite right. Something works in production and not in staging, or vice versa. So the pattern that we tend to kind of recommend and use on our projects is what I call the template stack pattern. And the idea of this is you go back to having a single project of Terraform, or it could be CloudFormation or whatever tool you're using. You have a single project, but if you apply it separately to each environment. So you make a change to your source code, and then you run it on your test environment. You test that, and then if that works, you take the same code and apply it on to the next environment, the next environment. And you might have some parameters to kind of set some of the whatever kind of things are different. Maybe the size or number of machines might be different in different environments, but that's all kind of controlled within the code. And so this gives you, this is basically, this is familiar, right? This is what we do with source code, right? If we have a Java application or any other kind of application, we don't have separate copies of our source code, separate repositories for each environment, and then copy and paste changes from one to the next. We build an artifact and we promote it along, and we have versions on our code. And so we want to do the same thing with our infrastructure. And so this gets us onto the second of the three practices I wanted to talk about today, and this is around the continuous validation. This is around, we want to test our infrastructure. And so if we can do continuous integration, which is that when we make a change to the code of our Terraform project, say, and we push that change, that we then automatically run some tests against that. And then if we're doing that, then we can kind of extend that as we did with the continuous integration for our applications and say, let's make a pipeline. Let's do continuous delivery and say, we're going to promote those changes from one environment to the next. And then we can use this pipeline for governance. So we can say that, and governance and operability concerns and things like that, we can say we're going to do security scans on our test environments to make sure that we have our networking rules and firewall rules and all those things are correct. And so this gives us, a bit more kind of control. And in terms of those kind of highly regulated environments, this gives us a really strong kind of case to where if we have auditors come in, we can say, we can show you exactly which, our production environment now, well, how did it get to that state? What changes have been applied to it? How the changes are applied? What tests we ran and the results of those tests? Who made which change when? So this gives us a really strong kind of audit trail for all of this. Now the challenge with this, with infrastructure in particular that kind of cloud level, those stacks, is the kind of speed, right? Because it takes a long time to spin up something in the cloud and then run tests against it. And so, and I think Effie and Shore are going to talk a bit later or after this about some more of this kind of stuff. But as kind of just to kind of the next, I guess, kind of practice that I had to talk about is around the design of things to say we're going to break our stuff down into smaller pieces, right? So if you have your environment and it's, it takes too long to spin it up and run tests against it, then let's break it into smaller pieces that we can test individually. And this is, by the way, coming back to the fact that this is the same stuff that we've been doing for software. This is just software engineering applied to infrastructure. This is essentially like, microservices, right? We're saying let's break the monolith into smaller pieces to make it more easily manageable. So there's two dimensions I'm going to talk about on how to break things down. And the first one is is breaking out the pieces of our stack into smaller things that can be tested separately. And server roles are a big one, right? So if you have servers within your infrastructure, whether it's because you're doing kind of virtual machines and deploying onto those, or even if it's with clusters, if you're doing Kubernetes, you may still be having to build your host nodes that you're running your application instances on, and you have to build those. So let's kind of break those out and test those separately, right? So if we have our stack, say, right, here's like say it's a CloudFormation or Terraform stack that we've defined, and it's got one of the servers there as an application server, say. And so we can define the role for that. And that might be like a chef role. It might be a playbook or an Ansible kind of role, or whatever the kind of tools are. But you basically have a tool to configure the server level things, what packages are going onto your server, and you say let's kind of define a role for that, and then let's make that role be composed of a number of specific, say, playbooks or cookbooks or what have you, which define different aspects of what goes onto those servers, right? So by doing that, we can test those server configurations separately and more quickly. We can provision them and test them locally on our kind of local desktop environment, or on a build agent, say a Go CD or Jenkins or whatever agent, can actually run these tests without having to provision anything in the cloud, especially for this, right? And so you get the kind of faster feedback on like how you're building your servers. And then the way the pipeline looks is we start kind of pulling things out into different branches. So we basically have up here, we're going to test our server configuration. So the idea here is that we have separate kind of stage for each, say that Java and that Tomcat monitoring agent. Each of the individual things that goes on, we run a test just for that piece. And if that passes, then we pass it along, and the next one there, the next brown box at the top there is like our application server role, where we pull all that together and say, does our application server hang together correctly and work the way it should? And if that's okay, then we're kind of pulling it in together with our stack definitions. So if it's a CloudFormation project, we say we're going to have, so we can potentially have the code that defines an environment without the actual application server. So it might set up some networking rules and so on. And so because it doesn't have servers and so on, it can be a bit faster to kind of spin up and then do some basic tests to say, does my routing work, right? Whatever it is that we need to test at that level is the kind of things that we put in there and say, let's test that separately before we put them all together, and then we can do some kind of lightweight tests across the whole thing and say, do those pieces, when they put together, do they behave as they should? And then as I mentioned, there's two dimensions to how we can kind of break down our infrastructure. The second one is the kind of that monolith. So going back to the microservices analogy, it's this idea that as our systems grow, we tend to have that Terraform or CloudFormation project gets bigger and bigger. So I've got a client that I've been working with in London where it takes them 2 hours to apply Terraform to an environment. So they've got how many people here use Terraform? Are familiar with Terraform? Yeah, okay, most of you. So they've got a file called rds.tf, which defines their databases on AWS. And it's got about 60 databases in that file. So you can see that it takes a long time to apply it. And so what we're working on with them is how to break this apart. We're doing the classic thing that we've done with applications when we go in and help people split their applications from a big monolith into separate pieces, and now we're doing that with their infrastructure. And we're saying, let's divide it into multiple stacks, multiple Terraform projects that can each be kind of handled on its own and applied on its own. And so each of those stacks has its own pipeline. And what we're trying really hard to do is to say, we can test each of those stacks independently of the others, so that what we want to avoid doing is building up this thing where in order to test my, say, application server stack, I've got to run like 5 other stacks to set up all the prerequisite pieces. This is forcing us to think about how we design our infrastructure. Again, drawing on lessons that we had from the application world. So we're using things like dependency injection and so on to say that we can we're not having our Terraform code for one project really tightly coupled with other Terraform projects. And then we have to think about what are good ways to draw those boundaries. How do we split up? Where do we split up that infrastructure? And we find there's a couple of kind of I guess rules of thumb for this. So I guess the first one, and maybe the most important one, is that it's based on your patterns of change. So what tends to change together should probably be things that go together into a stack. And so to avoid those situations where you're very often changing multiple stacks at once and then having to coordinate which one do we apply first. And another rule of thumb is around your kind of application structure, right? So it's like basically the way to kind of you know, to think about designing infrastructure in an infrastructure as code world is you start out with kind of like the users and what services and products or whatever are you offering to your users, and then that translates down into your application architecture, right? So what are we doing microservices? Well, what services do we have, and so on. We often will use like domain-driven design and event storming to kind of work out what our system ought to look like. And then that kind of maps down the infrastructure should be driven by that, by how is our application architected, and then also our organization, right? So it comes back to Conway's Law. How many people are familiar with Conway's Law? Yeah. So, you know, we want our organization structure and our system architecture to be aligned, because otherwise they end up with this kind of impedance mismatch, which creates a lot of friction. So we're basically saying, like, you know, within a kind of a team, the infrastructure boundaries should be kind of lined up with the team boundaries, so that we're not having to say we're going to change some infrastructure. We've got to coordinate across 5, 10 different teams and find the time that's good for everybody, because that just reduces the rate at which you can make changes to things. So I'm often asked, like, how do we start with this? If we have like an existing system, and maybe we're in the process of we're thinking about we want to move it to the cloud, or we're in the cloud and we want to kind of make changes to it and kind of re-architect it, re-platform it to kind of make it into a better situation, where do we start? And so the kind of trade-off, the common trade-off, there's two kind of approaches that people tend to take, right? One is the automate first or the platform first, right? So we're going to go away, we're going to build a platform. Then when we're done, we'll come back to the applications and say, move your applications onto our platform. And so that often takes like a year or 2 years. We spend a lot of money on that, and then when we come back to the application teams, they're like, this doesn't suit us at all. Like, you've just built something off in a vacuum. This is often the kind of like, you know, the technical teams who are like, oh, we want to kind of mess around with Kubernetes, want to build a Kubernetes cluster, which is fine, but it's like, you know, it needs to be done in conjunction with how it's actually going to be used to be successful. To the flip side, I've had a couple of organizations we've gone into where basically we said we're going to build, you know, automation. We want to move our applications into the cloud, move our systems into the cloud, and we say, great, we want to do this automation of the infrastructure, and we want to set up pipelines for infrastructure and testing for the infrastructure. The thing is, it's not easy, right? So it's a lot of work to build this stuff, and especially I think a lot of the tools are still they're not super mature, and particularly in terms of testing. So I think the where we are as an industry and with the infrastructure tooling has still got a ways to go to really make it easy for people to pick these up and use them on a project. And so what happens is you end up spending a lot of time on the basics of, like, we're going to set up new CI/CD servers. We're going to, and the teams may be learning for the first time how to use these particular infrastructure tools. How to write tests for infrastructure is really hard, and we're having a lot of discussions within, even within our kind of Thoughtworks groups around what are the best approaches to take, what works and doesn't work. It's a real learning process for the industry. And so what we'll sometimes hear is like, oh, let's just leave that for later, right? Let's build the thing in the cloud, and then we'll go back and we'll add the automation to it afterwards, right? So how many people here have tried to write unit tests for an existing system that didn't have any tests? Say, let's go back and write it, right? Okay. So how many people found that a really easy thing to do? And nobody. So this is the thing, right? So basically, the whole point of automation is that it's a delivery thing, right? And I think some people don't quite think about that. They think of automation as something you do afterwards to kind of like lock in your system design and your implementation. But the point of automation is to make it easy to make changes, right? Especially all these kind of tests and stuff. It gives you the confidence and just the ability to move quickly and make sure that you're building the right thing and building it well. So you kind of have to do that as a part of your building process. And then also, it impacts your system design, right? So tests, in order to test, especially if you're going to avoid having we have to spin up the entire system as a whole and then run tests across that. If you're going to say we want to do tests at the kind of smaller level of our components and things to make that more tractable, basically. That means that your system has to be designed and built so that you can do that. And you don't tend to do that automatically, right? We talk about we're going to make our system nice and componentized and all of that, but in the kind of as you build, that tends not to happen. And tests force you to do that. So this is the whole thing about having the pipelines and saying, like, we're going to build each of our Terraform projects and make sure that we can build it independently without having to stand up any other infrastructure. Like, the pipeline forces that. If you write some code which assumes this other project is already there, and we're going to go and kind of use things about that and have a lot of deep knowledge across our code projects, like, it'll break, right? Because the pipeline is going to deploy it by itself, and it's like that thing isn't there, right? So it's a way of kind of enforcing the discipline and enforcing good design. And so the kind of, I guess, nutshell is that we have to automate as we build our things. And in order to do that, we have to kind of build incrementally. And this is building the functionality or whatever it is that we're building, whether it's a new thing we're building or as we're migrating things to the cloud, we have to think about what's a small piece that we can start with and build just that. What automation do we need in order to deliver that? And what's the simplest automation for that, right? So we're not trying to build the whole platform or the whole kind of automation infrastructure and systems and all that we're going to need for the whole system. It's like, what's the kind of smallest piece we can build? And that's still going to take longer. For the first pieces, it takes longer than you think it should. You might think, oh, here's a bit of an application we're going to move to the cloud, and it really should just take like maybe a few weeks, and it might take a few months. But then the next thing that you build, okay, we've already got some pieces there, and maybe we're going to iterate on those and like change out some of the tools that we picked for the first part. But it's going to kind of, it's going to get faster and faster as we go. And so, yeah, so that's basically what I've got to say on this. I'm happy to take questions. Thank you.